Okay, looking at Unit 7 test review. Number 1, we've got it campsites F and G. At those points, there are campsites on the opposite sides of a lake. Survey crew made the measurements shown on the diagram. What's the distance between the two campsites? So what we're looking for is the length of FG. All right, so we are going to say that these are similar triangles because we've got congruent vertical angles, and if we take 82 we don't know that the triangles are similar, but we can figure that out, and corresponding sides would tell us that 82 and 73.8 are corresponding if these are parallel lines. So we would take 82 over 73.8, and when we divide that we get 1.1 repeating. Then we take the other corresponding sides and say 92 over 82.8, and that also equals 1.1 repeating. Therefore, these two triangles are similar because of side similarity. Since they're similar, we can take the ratios and find the value for x. For instance, we can say that 47 over x, since those two sides are corresponding, are going to be equal to 82 over 73.8. Then we'll cross multiply, solve for x. When we cross multiply, we get 82x equals 3,468.6. Divide by 82, and we get x equals 42.3, which is A. Okay, moving on to number 2. Find the perimeter of ABC. ABC is a large triangle. It's similar to PQR, which that's PQR, ABC. I'm sorry, I did that wrong, didn't I? Yeah. That's B, that's C. Okay, the perimeter of PQR is 36. AC is 12, so this whole length is 12. PR is 6. Okay, notice that AC and PR are corresponding sides of the triangle. So that ratio is 12 over 6. Now you'll recall the perimeter of PQR is the smaller triangle, so it's going to go on bottom. But the perimeter is also has the same scale factor as the corresponding side, so we can set our equation up like this. And when we do that, we cross multiply, we get 6x equals 12 times 36, which is 432. And then we'll divide by 6. And we get x equals 72. X, remember, was the perimeter of ABC. So that is my answer. Okay, number 3. Find PS. So we're looking for, let's see, this is P, R, S, Q, that's a 10. That's A, B, C, D, that's 16, that's 12. Okay, so they're similar triangles. AD is an altitude of ABC. PS is an altitude of PQR. AD equals 12, AC equals 16, PR equals 10. Well, if you'll recall, we're looking for PS, this altitude. Its corresponding side is 12 AD, so 12 over, we'll call it X, the unknown. That ratio is going to be equal to 16 over 10. Corresponding sides. Cross multiply, 16x equals 120. When we divide by 16, we get x equals 7.5, which is our answer. Okay, looking at number 4, we've got two triangles, and we're deciding which of these statements is true. Are they similar? Well, when I look at the angles, we have 40, 40, 117, 117. They have two angles that are congruent. I'm done. I don't need to look at anything else. They are similar. So we can eliminate A and C, because those say that they're not similar. If we were to make a triangle similarity statement, we have to look at these terms right here and see which of those is accurate. D corresponds to the other angle that's 40 degrees, which is B. So right off the bat, we know that B is our answer. So BAC would be the corresponding triangle. And the ratio of correspondence, you'll notice that all the sides are equal to each other or congruent. So when they are congruent, we have a ratio of 1, or a scale factor of 1. Because we would multiply this times 1 to get this. Alright, another one that's hard to read. It says each pair of polygons is similar, write a similarity statement. So they are similar, and then we need to find the scale factor. So we would look at the angles, and I have 46 here, 75 here, and 59 here. On the other triangle, I have 59, 75, and 46. A, B, C, D, E, F. So if I'm looking at the triangles, DEF is written in the answer key, so what angle corresponds to D? Well, that would be C, because they're both 59 degrees. What angle corresponds to E? That's 46. B is the 46 degree angle, and that would leave us with A, so it would have to be CBA. Then they want us to solve for X. We would have to do a ratio. So corresponding sides, we would have 6.3 on this side. So you would say 6.3. And that side corresponds to X. So that would be equal to, we have this 21.66. That would go on bottom because I put my X on bottom. And the side corresponding that would be 5.7. Cross multiply, solve for X. When I do that, I get 5.7x equals, and I'll get a long decimal. I'm really not going to put that, because I'll let you calculate that on the calculator. Actually, it's not too bad. 16.758. Then I'm going to divide both sides by 5.7, and that gives me x equaling 2.94, which is not correct. I did something wrong here. Yeah, that didn't make sense. I the product right here should not be 16.758. 21.66 times 6.3 is 136.458. Then I divide that by 5.7, and I get 23.94. So that leaves me with an answer of C here. If x is that value, then that means that the length of CB is the same value, and AB would be, we could do a ratio, but what we see from the answer choices that that's the only one that can possibly be correct. And we can find this scale factor by taking the corresponding side, such as 21.66 over 5.7. That's going to give us, divided by 5.7, that's going to give us 3.8, which is the scale factor right here. Okay, moving on, looking at number 6. For problem 6 through 7, determine whether each pair of triangles is similar. These triangles, they are similar because of they have a side that's congruent. If a side's congruent, then they are going to be similar because the scale factor is going to be 1. So, and then they have a congruent angle. So that's going to be congruent by side, angle, side. These two triangles, notice that they have two angles that are congruent. Therefore, it doesn't matter what the sides are. It's going to be from angle-angle similarity. But I have two with angle-angle similarity, so I have to be careful what I write. They both have EDF as the first triangle, so we have to find out what angle is corresponding to E. That would be B, since that's the one that's congruent to it. Therefore, we know that A is the correct answer there. It's the only one that starts with a B. Okay, number 8. QS and PT are parallel. Therefore, well, and we know that PQ is 18 and QR is 6. RS is 12. RS is 12, that's there. And ST is 36. So now we are not told that they're parallel. That's our job. We're going to determine if they're parallel. Well, they're parallel if these sides are proportional. So we're going to take 6 over 18 and set it equal to 12 over 36. If I cross multiply and get the same thing, then they are parallel. But look at 6 over 18. That's going to simplify to 1/3, isn't it? And 12 over 36 also simplifies to 1/3. They are the same. Therefore, the lines are parallel. So anything that says no is going to be incorrect. And PQ over QR equals ST over SR, which is 3. Now they flipped it. They wrote PQ, so theirs looks like 18 over 6 and 36 over 12, which is 3 equals 3. They're both equal to 3, which is why C is my answer. Okay, and number 9, find the length of AE if the lines are parallel and BD is a midsegment. So BD is the midsegment. Notice that I'm at 3 here and I'm at -4 here. So the length of that long segment is 1, 2, 3, 4, 5, 6, 7. 7 for this long segment. Remember, the midsegment is half of 7, so all I have to do is take half, and actually they're wanting to find AE, which is 7. Yeah, that was simple. There was actually nothing. If I thought they were asking for dB, which if they were asking for dB, it's half of 7, which would have been 3.5. Okay, C, determine whether each pair of triangles is similar. all we're given here are lengths, side lengths. So we're going to see whether they are all proportional. Let's go ahead and put the D, E, F, A, B, C. So we're going to say that 8 is the smallest side in the first triangle, and 24 is the smallest side in the second one. That simplifies to 1/3. Second smallest is 9. 27 is the second smallest. That also is 1/3. And then we have 10 over 30 is 1/3. So yes, they are similar. Now, notice they all are side-side similarities, so we know that that's going to be the case. Now we just have to write the correct similarity statement. EDF. So E is opposite the smallest segment. So what angle is opposite the smallest segment? That would be B. So E and B correspond. Next we have EDF. D is opposite the longest segment. What angle is opposite the longest segment in my second one? C. So it would be BCA, which is C. Okay, look at number 11. Are those similar? Well, look at, it's the same case. We've seen this problem before. They have a pair of sides that are congruent, therefore the scale factor is 1. They have congruent. So they are similar because of side, angle, side similarity. D is the only one that has that option. And then we have A. Again, they have angles, two angles that are congruent. So it's going to be angle, angle similarity. Not this, not angle, side, angle. So now it's a matter of getting the correct angles corresponding. We have EDF. So corresponding to E would be B. Corresponding to D would be C. Corresponding to A would be, or to F would be A. So our answer would be BCA, which is C. Okay, let's look at number 13. Number 13, we have two fractions equal to each other. These are basically two ratios, a proportion problem. We can solve it by cross-multiplying. 5 times y is 5y, and 4y minus 12 times 5 will have to be distributed. So we've got 5y equals 20y minus 60. So we'll subtract 20y and get our y's on one side. We end up with negative 15y equals negative 60. So we'll divide by negative 15. Sorry, I'm all over the place. And y equals 4. Okay, and here I have some values. They give me that PQ is 19, QR is 9, RS is 18, and ST is x plus 1. And it's saying to prove that these two segments are parallel. Well, if they're parallel to each other, we should have a proportion. They should be proportional. The segments that are divided by specifically QS. So we have 9 over 18 should be proportional to 18 over x plus 1. So we're going to cross multiply. 18 times 18 is 342. And then 9 times x plus 1, we distribute 9 and get 9x plus 9. Subtract 9 from both sides, and we get 333 equals 9x. Divide by 9, and we find that x equals 37. So that's the value that x would have to be in order to make the sides proportional and make those two lines parallel. Okay, Number 15, we're going to explain why these two lines, why these two triangles are similar, then find the value for x. So we've got this small triangle, and then we've got the larger triangle. We've got 5 here, 12 here, 3 here. This is x. The two lines are parallel. And so we find that they share this angle, which makes that angle congruent. And if these two lines are parallel, well then these two angles are going to have to be congruent as well. So since we have two angles that are congruent, the triangles are similar because of angle-angle similarity. Now that means that the corresponding sides are proportional. So if I go 5 over 5 is the side of the blue triangle right here. Well, the green triangle's length is 8, so we could go 5 over 8 equals this side, the blue triangle, 12 over the length of the green side right there is going to be x. So we're going to cross multiply, and we get 5x equals 96. Divide by 5, and x equals 19.2. Okay, let's look at number 16 now. I'll draw some things in that triangle as well. So we have an angle bisector. And I have lengths 5.9 and 4.9. And then I have lengths of 11.2 and x. Now you remember, an angle bisector creates two segments that are proportional to the sides. So I can say 5.9 over 4.9, that's going to be proportional to x over 11.2. Cross multiply, and I get 4.9x equals 66.08. Divide both sides by 4.9, and x equals 13.48. If I round to the nearest tenth, which is what the question asks, 13.5 is the value of x. Okay, number 17. You have this figure below. Are CBD and CAE similar? Well, it says that these two lines are parallel, which means they share angle C, so they have a congruent angle there, and they also have this angle congruent because of corresponding angles. So, yes it is. Why? Because of angle-angle similarity. Now using the same diagram, if BC is 6, so that's the whole length is 6, that side, AB is 8, AE is 21, what is the length of BD? We'll call it X. And when I said BC, I'm sorry, that wasn't the whole length, it was just this segment. So 6, which is BC, corresponds to the length of AC, which is that side of that triangle, which 8 plus 6 would be 14 there. The red is 14. That's going to be equal to x over 21. Cross multiply, we get 14x equals 126. Divide by 14, and x equals 9, which is the length of BD, x. Okay, number 18. We've got two angles, and you'll notice that the two triangles are similar because they have two angles that are congruent. The 90-degree angle, and then they have the angle right here being congruent. So, we're going to say that let's see, what are we missing here? Am I missing something? Yes, we are. We don't have all the sides. This side, x, is corresponding to this side, but I don't know the length of that side. Notice that it's a right triangle, and since it's a right triangle, we can call it y for now, but y squared plus 4 squared is going to equal 5 squared. You might recognize this triangle as well because it's a perfect triple. And what I mean by a perfect triple, as I'm solving this, you'll see that y squared equals 9. Well, the square root of 9 is 3. A perfect triple just says that there's a right triangle with side leg lengths of 3 and 4 and the hypotenuse of 5. So you may have recognized that, or you could have figured it out with the Pythagorean theorem. So now we know that 5 over 7 corresponding sides, that's going to be equal to corresponding sides of 3 over x. Cross multiply, 5x equals 21, divide by 5, and x equals 4.2. Alright, now we have this bunch of questions. All rectangles are similar. That's not true. We could think of a couple examples or several examples. If I have that rectangle and then I have that rectangle, those are definitely not similar. So that answer is false. All squares are similar. Squares all have 90-degree angles, and the sides are all proportional because the sides are all the same length. So yes, that is true. All squares are similar. All equilateral triangles are similar. All their lengths are 60 degrees, and all their angles are 60 degrees, and all their lengths are equal to each other. So we could multiply one by a scale factor, and they would all be multiplied by the same thing. So yes. If two shapes are congruent, then the ratio of similarity is 1 to 1. That is true. Basically, you have a scale factor of 1. All isosceles triangles are similar. Absolutely false. Their angles could be very different on isosceles triangles. All circles are similar. We've talked about that. That's true. All rectangles are congruent. Well, we just have two examples here that show you that all rectangles are not congruent, so that's false. A square can be similar to a triangle. No, it cannot be. I'm not even going to read that one further. They have to have the same shape. Congruent figures are always similar. That's true because if they're congruent, then they have the same shape. They also have the same sides. They just have a scale factor of 1 to 1 like we saw up here. If f is similar to g, then it's congruent to g. That is false. It could be larger, it could be smaller. It doesn't mean it's congruent to g. K, if f is similar to g is similar to h, then f is similar to h. Yeah, if they're similar to the same figure, then they're going to be similar to each other. That's true. And then we have an example here. Are these two triangles congruent? The answer there, what is the angle that we're missing? 106, 74. So this angle here is 74 degrees. That's 73.38, and that would make that angle 111.69, I believe. The angles aren't the same, so it's false. And even if the angles were the same, we really couldn't tell if they were or not because the triangle lengths, the side lengths, we don't know if those are congruent. Okay, moving on to number 20. Basket holding 35 pieces of fruit has apples and oranges in the ratio of 2 to 5. Find the number of apples and the number of oranges in the basket. So 2 times a number plus 5 times the same number is going to equal 35. We end up with 7x equals 35. Divide both sides by 7 and x equals 5. That means that 2 is the number of apples. So 2 times x, which is 5, would be 10. 5 is the number of oranges. 5 times x, which is 5, would be 25. oranges. Right now, looking at number 21, we've got similar figures here in both A, well not B, but A is, we're told that they're similar. We're supposed to find Q and R. Now remember, the ratios are formed by corresponding parts. AE corresponds to JN, so we have a ratio of 20/8, which should be proportional to, we're looking for Q and R, so Q is corresponding to 7. We put 20 on top, so Q goes on top, and 7 goes on bottom. Cross multiply, 8Q equals 140. Divide by 8. I put an X, but it should be a Q. And we get 140 divided by 8. Q equals 17.5. Now we do the same thing for R. We use the same ratio, 20/8 is equal to R over 5. Cross multiply, 8R equals 100. 100 divided by 8 equals 12.5. Okay. Now for B, we don't know if they're similar, but we do know this angle is congruent. And since we have parallel lines, we know that alternate interior angles are going to be congruent. So this triangle is indeed similar. So the corresponding angles that we know of are 6 and 5. And we're looking for Q and R again. Q corresponds to 4. So we put 6/5. 6 was first, so 4 is going to be first. 4 over Q. Cross multiply, 6Q equals 20. Divide by 6. And Q equals 3 1/3. Now if I'm doing the R, I'm going to use the same ratio. 6/5 is equal to, I put 6 first, so I'm going to put 9 over R, corresponding sides. Cross multiply, 6R equals 45, divide by 6. 45 divided by 6 is 7.5. Okay. Moving on, number 22. We're finding X here. So number 22, this is an angle bisector. You'll recall that an angle bisector, these are sides, the segments that it splits that up into are going to be proportional, 4/3, to these sides. 4 was first on top, the numerator, so x plus 2 is the numerator. Cross multiply, when I do that, I get 4x minus 4. I just distribute that 4 to x minus 1, equals 3 times x and 3 times 2. Subtract 3x, add 4, and we get x equals 10. Just solving it algebraically. Okay, so now we have these two segments. They are going, the triangles are similar because we have two angles that are congruent. And what we have are two ratios, x, x over 15 is equal to 5/3x. So, cross multiply, we end up with 75 equals 3x squared. Solve for x, and x squared equals 25. We'll take the square root of both sides, and we get x equals 5. Okay, and the next one, we got altitude coming down. These two triangles are similar, so yes, we still do have proportional sides. X over 14, corresponding sides, is equal to 7 over 2x. 98 equals 2, that's when I cross multiply. X times 2x is 2x squared, divide by 2, and 49 equals x squared. Take the square root of both sides, x equals 7. Alright, determine whether each pair of triangles is similar. Well, we're going to have to see if the sides are proportional. So, 3 over 12, looking at this, is equal to 1/4. 3 over 12 equals 1/4. And then 2 over 8, if I simplify that, that's also 1/4. All the sides are proportional, so ABC is similar to DEF. And we justify that by side, side, side similarity. All the sides were proportional. Okay, we have another triangle. They share, remember that we've got this blue triangle and the green triangle. Now they share this angle, so that's congruent. We've got parallel lines, so corresponding angles are going to be congruent to each other. We have two angles congruent, therefore XWV is similar to YWU. We justify that by angle-angle similarity. Okay, 27. Are they similar? Well, we've got sides that are congruent. If they're congruent, then they're also similar because they would have a scale factor of 1. And in between the two sides, we have angles that are congruent. So yes, XYZ is similar to X corresponds to Q, Y corresponds to S, and Z corresponds to R. And we do this with the side angle side similarity. Alright, and 28, it's going to be very similar to the one we did above. We've got numbers 4, 8, 10. Down here we have 12, 22, and 30. So 12 is the shortest side. We've got 4 over 12. That simplifies to 1/3. Then we've got 8 over 22, which simplifies to 4 over 11. Those two are not the same. That means these two triangles are not similar. Okay, remember, if we're going to use side-side, we have no information on angles. If we're going to use side-side-side similarity, all sides have to be proportional. 10 over 30 simplifies to 1/3, but this one here does not. So not similar. Okay, number 29. Are these two similar? Well, look at this. This one's kind of tricky because when we check the ratio, RS is corresponding to YX, so 5.5 over 11. Sometimes it's easier to write the decimal than to simplify the fraction. So we'll go 5.5 divided by 11. We get 0.5. And actually that one would have been fairly easy. The next side is 4.5 over 9. When we simplify that, we also get 0.5. They've got two sides that are proportional, and they've got an angle that's congruent. So wouldn't that sound like side angle side similarity? Well, the problem here is this angle has to be in between the two the two proportional sides. So this one, the answer would be no. We could not prove that this triangle was indeed similar. Kind of a tricky one there. Determine whether the dilation from A to B is enlargement or reduction. Now, enlargement to reduction from A to B, does it get bigger? If it gets bigger, then it's enlargement. If it gets smaller, it's reduction. Definitely from A to B it gets smaller, so reduction would be our answer. Our scale factor is, we would find the lengths of the sides, and this side is 5 by counting, and this side is 8. And for B, we have 2, and then we would have 4. I'm sorry, that wouldn't be 5, that would be 4, wouldn't it? So the scale factor from A to B, notice it's getting smaller, so my scale factor, has to be less than 1. So 1 is greater than my scale factor because it's getting smaller. So if I'm using these two numbers, I'm going to put 4 over 8. If I had put 8 over 4, that would give us a scale factor of 2, and we're not multiplying 8 times 2. What are we multiplying 8 times to get 4? Well, that would be 1/2. That is my scale factor, 1/2. It's getting smaller. Okay, find the geometric mean between these two numbers. Well, the square root of 256 is 16. The square root of 841 is 29. So we're looking for the square root of 16 times 29. And when I multiply 16 times 29, I get 464. The square root of 464 is 21.5. Now, yeah, that would be my geometric mean between those two numbers, 21.5, and we rounded to the nearest tenth. Okay, find x. We've got x here. We have this length is 4, this length is 6. So you'll recall that the altitude, or the leg, x, is the geometric mean between the segment adjacent to it times the length of the entire segment, which would be 10. So x is equal to the square root of 40. If I simplify that using the cake method, I would only have one pair of 2's to pull out, and 2 and 5 would stay inside, so 2 times 5 is 10. That would be the value of x. It's the length of that leg. If you figured it out as a decimal, the square root of 40 would be 6.3.